Hey everybody, this is Mr. Charnetsky, and this is Unit 4, Lesson 2, least square regression line, or we can call it a linear regression line. Essentially what we're going to learn in this lesson is if we have a set of data, can we determine if there's a linear relationship? In other words, does a straight line fit our data well or not? And then can we then use that prediction, that regression line, which is actually just a computer generated line, can we use that to make predictions about things in the future or other sets of data? Excuse me. So first thing to do, let's take a look at this first problem here. Sam found how many hours of sunshine versus how many ice creams were sold at a shop from Monday to Friday. Here's our number of hours in the day, and here's the number of ice creams sold. All right, so what we're going to do is we're going to go to Desmos. I already have one up, and I'll just open up another tab here. We'll go ahead and graphing, and then I'm going to click on the plus to create a table, and essentially we're just going to match this exact table. We're going to put in our x column these numbers, so 2, 3, 5, 7, 9, and that was it. Yeah, 2, 3, 5, 7, 9. And then we had 4, 5, 7, 10, 15. Okay. And we can see over here on the right, some of our data is being plotted. We're missing some of the upper ones. We could click and drag, try and find the rest of these, but a better way, because later on we're going to be using bigger numbers here, a better way is to click this graph settings, this little wrench here, and then on the x values, find your lowest x value, and then go under that by a little bit. So if our lowest x value is 2, we should go to maybe 0. And then our highest value for x is 9, so maybe we go to 11. Okay. And then we do the same thing for y. So our lowest y is 4, so maybe we'll make 0 our y again. And then our highest y is 15, so maybe we go, I don't know, something like 20. So that way I've got all of my data points. And then the first thing that we do, I mean, from here we can zoom out a little bit more, move things around how we like, but this at least assures that we get all of our data in one picture here. So first thing we do is we look at our data and we think, okay, does it even look linear? Does it look like, or does it look random? And it actually does look pretty linear, and it looks like it's a positive linear relationship. Okay, so that tells us we should probably go ahead and do a regression. And the way that we do that in Desmos is we type in something that almost looks like the linear equation that you were taught in algebra, the y equals mx plus b, but it's not quite y equals mx plus b. We're going to type in something close to that. So it's going to be y1, and we do y1 because that's our list here for y1. And instead of an equal sign, we're going to put a squiggly line. And the squiggle line, if you look at the top left of your keyboard, sometimes it's called a tilde. It's right next to the number 1 above the tab, and you have to hit the shift button to get it. So you get this little squiggly here. Okay. So y1 squiggly, m, like our slope m, x1, so again matching our x1 here, plus b. Okay, so it's almost like y equals mx plus b. We just have a few changes. Instead of just y and x, we put our y1 and x1, and instead of an equal sign, we got that little squiggly. And what that does is it tells the computer, hey, draw a line that fits best to our data. Okay. And the equation for this line, we actually are told what the slope and the y-intercept is right here. Here's our m for our slope. Here's our y-intercept b. So my actual equation for that line, I could type it in, y would equal 1.51829x plus 0.304878. So that would be my line. You can see this equation that I typed using the slope and the y-intercept here that they gave us. That fits right on top of the line that they gave us before. Okay. I'm going to get rid of that. All right. So now we want to use this to make predictions. So our notes say predict. Actually, I have the answer here. Predict what our the amount of ice cream sold for 12 hours of sunshine would be. So we're going to go ahead and do this. So we'll type in x equals 12. And what that does here is that creates a vertical line that's going to intersect our prediction line, our regression line. And if we click on it, it's going to allow us to make a prediction here. So here's our days, our amount of sunshine, 12 hours, and it's going to say predicting we're going to sell about 18.5. 18.5 ice creams. Okay. All right. Next, we have some data here. We have the height in inches of 8 high school girls and their, before we actually move on to that, let's actually go back to our graph here and talk about, well, is this actually a good fit and would this be reasonable prediction? So our R value is our correlation coefficient. So this number right here, not the R squared, but the R, this tells us how good a fit our data is. And the closer it is to +1 or -1, so anything 0.9 and above is a really good fit. So this is telling us that this is very much a linear relationship. Okay. If we get really close to 0, then that's going to be a not so good fit. So, all right, let's go ahead and clear this out. And we're going to look at the relationship between the height in inches of 8 high school girls and their IQ scores. See if there's some sort of relationship there. Okay, so let's go ahead and plug in those numbers. Well, first we got to create a table. Okay, so for our x, we have 62, 8, 65, 67. 59, 64, 65, and 57. Okay, and then our corresponding IQ scores, we got 109, 102, 107, 114, 6, 10, 6, 128. Okay, so same thing, we're going to create a regression line. So y1 squiggly mx1 plus b. Okay, so we can't see our line or our data, so we should actually go to our wrench here and change our x values. So our lowest x value looks like 57, so maybe we make our lowest x value 50. Our highest x value is like 67, so maybe we go to, I don't know, 75. Lowest y value is 96, so maybe we go to 90. Our highest was like 128, so maybe 5. And just a little extra zooming. So here's our data. I'm going to turn off our graph for just a second. So just looking at our data doesn't look like much. Looks pretty random to me. And when we try and fit our line in this, we can see that our R value is actually quite low here. It's 0.1. It's almost close to, basically close to 0. So there's not much of a correlation. In fact, I would say there is no correlation here. So there's really no point in trying to make a prediction, because even common sense will tell us that there's really no relationship between your height and your IQ. So we're not going to do any sort of predictions with this one. So we got our data and our scatter plot. So if I was describing this type of correlation, I would say there is no correlation between height and IQ. Okay, that's it for this video.